In this lesson, we're going to talk about rotations, and we're not going to get super detailed about rotations. I will say out of all the transformations, I think they're one of the more difficult, but if we can remember some basic things about rotations and what their rules look like, then we can be successful on identifying and looking at rotations. Okay? So it says what is a rotation? A transformation is where an object is turned. So it's exactly what you think it is. We're rotating it. We're turning the object. A figure is always rotated around a point or center of rotation. Now, as you progress through math, that center of rotation will get a little bit more difficult. But this year, our point of rotation is always going to be the origin on the graph. And so remember, the origin is at 0, 0, 0. When a figure is rotated, it will change a couple of things I want to note. When a figure is rotated, number one, it will change quadrants. It will change quadrants. And I just want to remind you, we've talked about this a little bit, but when we talk about the quadrants on a coordinate plane, quadrant 1 is right here. This is the positive quadrant. Quadrant 2 is here, so it's going counterclockwise. This is quadrant 3, and this is quadrant 4. That's important to know because you'll get questions about what quadrant did it move to. Okay? Also, when a figure is rotated, it will change direction. It will change orientation. We've been talking a lot about orientation. And so remember, a rotation is one, because we are turning it, it's going to change which way it's pointing. And then another comment to make is that all we're doing is turning the object, and so I just want you to keep in mind that rotations stay congruent. So even though it's pointing a different direction, it is still the same size and shape. Okay, so we have several different types of rotations, only types in the degrees that we turn it. And think about it like a car or a skateboard rotating or turning, okay? A 180-degree rotation is actually the easiest, and it doesn't matter which way we rotate. If we rotate left or right, a 180-degree rotation still ends up in the same place. This is going to end up being 2 turns of our object. And so what I want you to think about is it's going to move 2 quadrants. Okay, it's moving 2 quadrants. Now when we I want us to look at it and explore our rule. So remember, the first thing we want to do is identify which one is our pre-image. And so I'm going to highlight here my pre-image, remember, is the one that doesn't have the prime notation. So this is my pre-image. And I want us to take a minute and go over here and write down our coordinates for our pre-image for this trapezoid. Point K would be 0, -4. Point L would be 4, -4. Point M, 4, -2. And point N, 1, -2. Okay, that is our pre-image. And so now let's go look at our coordinates for our image. K prime is 0, +4. Point L prime is -4, +4. M prime is -4, +2. And N prime is -1, 2. Okay, so let's look at these points. What happened? What happened from the pre-image to the image? What do you notice? I hope you noticed that the numbers stayed, for the most part, in the same place. They stayed in the same place, but what did they do? What did they do? They changed signs. They changed signs. So let's look at point N. You see how we still have a 1 and a 2 as the x and the y, but it went from positive 1 to negative 1. And it went from negative 2 to positive 2. And here, same place, but we went from positive to negative, negative to positive. Here it kind of looks like they switched places just because they're both 4s, but really all we did was change signs. Here 0 can't be positive or negative, so it's just 0, but do you see how the 4 changed signs? And so a 180 rule is super, super easy. The algebraic rule would be that we take the point, take the original point, and then all we have to do is write the opposite. Remember, putting a negative sign means do the opposite. Put the opposite value. Positive, negative, negative, positive. It's also like multiplying by negative 1. Okay? So 180 rules, super, super easy. And think about it, because we're doing 2 turns, both numbers are changing. Okay? Now, 90 degrees and 270s are a little bit trickier. A little bit trickier. Okay? I do want to comment that figures can be rotated clockwise. Okay? Clockwise would mean that it's going to the right and moving around like a clock. Or we could rotate it counterclockwise, which means our object is moving the opposite. It's going, starting, and moving to the left. Okay? And 90-degree rotations and 270-degree rotations are very similar. First of all, 90 degrees, I hope we realize, is 1 turn, which means it would change 1 quadrant. 270 rotation is 3 turns, which means it would change 3 quadrants, right? It would move 3 times, okay? And so we're not going to get really specific because it depends on if we move counterclockwise or if we move clockwise. It kind of depends on what the rule is. But all we need to know for this is we're going to be just very simple. What we need to know about these types of rotations is that the x and y values will change places. And just one of the values will become the opposite. Just one of the values will become the opposite. So let me show you what I mean. So you have 2 options that could happen for 90 degree and 270. We take the point, and the first thing we said is that x and y are going to change places. So I'm going to change places, and then one of them is going to become the opposite. So that's one possibility. Or the rule could be this. Take the point, x and y change places, but this time the x is the opposite. So this is all we need to be able to realize for a 90 degree and a 270 rotation. And what I want to tell you is this is very similar to a reflection. But remember, reflections, and I'm going to make this note here because hopefully you're listening and writing, reflections do not switch places. Reflections do not switch where x and y are. Only rotations switch where the x and y are.